In order to analyze data, we need to produce data. In Chapter 8, we'll talk about sampling. The concepts include the distinction between population and sample, ways that you can sample badly, simple random samples, making inferences about the population, other sampling designs, and some cautions about sample surveys. The distinction between population and samples is basic to statistics. To make sense of any sample result, you must know what population the sample represents. The population in a statistical study is the entire group of individuals about which we want information. The sample is the part of the population which we actually collect information. We use information from a sample to draw conclusions about the entire population. So this is sort of a cyclical thing. We sample from the population. That makes a representative sample. And then we make an inference from that sample about. So here's an example. A department store mails a customer satisfaction survey to people who make credit card purchases at the store. This month, 45,000 people made credit card purchases. Surveys are mailed to 1,000 of these people, chosen at random, and 137 people return the survey. So what is the population of interest for this survey? The population is the 45,000 people who made credit card purchases. What is the sample? In other words, from what group is information actually obtained? In this case, the sample is the group of 137 people who returned the survey, not the 1,000 who received the survey. How to sample badly? There are many ways to do this. First off, the design of a sample is biased if it systematically favors certain outcomes. Choosing individuals who are the easiest to reach results in a convenient sample. A voluntary response sample consists of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions, often in the same direction, are the most likely to respond. So here's an example. A sample of mall shoppers is fast and cheap, but people at shopping malls tend to be more prosperous than typical Americans. They are also more likely to be teenagers or retired. Moreover, unless interviewers are carefully trained, they tend to question well-dressed, respectable-looking people and avoid poorly dressed or tough-looking individuals. The type of people at the mall will also vary by time of day and day of week. In short, mall interviews will not contact a sample that is representative of the entire population. Online polls. Former CNN evening commentator Lou Dobbs doesn't like illegal immigration. One of his broadcasts in 2007 was largely devoted to attacking a proposal by the governor of New York State to offer driver's licenses to illegal immigrants as a public safety measure. During the show, Mr. Dobbs invited his viewers to go to loudobbs.com to vote on the question, would you be more or less likely to vote for a presidential candidate who supports giving driver's licenses to illegal aliens? We're not surprised that 97% of the 7,350 people who voted by the end of the broadcast said less likely. Most opinions, and they're listening to Lou Dobbs. Random sampling, that is, the use of chance to select a sample, is the central principle of statistical sampling. A simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has the exact same chance to be in the sample as everyone else. In practice, people use random numbers generated by a computer or calculator to choose samples. Gone are the days of picking numbers. Here's a classic example. of not a simple random sample. On election night in the 1948 presidential election, the Chicago Tribune printed the headline, "Dewey defeats Truman." Truman was actually the president at the time. He was running for re-election. The Tribune used a telephone survey to gather its data. Problem is, in 1948, many people didn't have telephones. Those who did tended to be prosperous, which also meant they tended to be Republicans. Dewey was a Democrat. Sorry, Truman was a Democrat. Okay, here are some other examples of not so good random samples. I'm taking an opinion survey of college students. So I will collect a random sample of students by selecting students at the campus dining hall. Well, sounds nice, except this doesn't catch the students who don't eat at the dining hall. For example, commuters, people who live at home, people who live off campus, and that type of thing. So their opinions will not be represented in this survey. I could distribute surveys through the campus mail system. Again, for people who live at home and probably off campus as well, they're not going to be represented in the sample because they don't use the mail system, the campus mail system. Okay, here's another example. I'll select 7 students from the class. These students will automatically get an A for the course. Okay, so I'll start. In my first sample, I'll just read the first 7 names from the class roster. So I do this. Okay. So what's the probability that Ch08mp4 gets chosen? 0. Because that comes at the end of the alphabet. So this is not, in fact, a random sample. Suppose I just pick students from the front row. I'll just point at them. Well, there again, the people in the back of the room have practically no chance of getting picked. So these are not random. So to choose a simple random sample, we give each member of the population a numerical label of the same length. We number them. And then using a computer, most often, we'll choose n random numbers between 1 and the population size. And most statistical software has an option for generating sets of random numbers. I'll show you how to do that in Excel in a minute. The individual whose numbers are randomly chosen become your sample. There's no systematic bias. Every number has the same chance of getting chosen. So, here's a list of 28 hotels. We're going to pick a simple random sample of 4 of them. So in Microsoft Excel, for example, we can enter the formula equals rand between 1, 28 in some empty cell. This generates a random integer between 1 and 28. And then we do this for another 3 cells so that we have a total of 4. If for some reason one of them is repeated, we just do it again. Just add another cell and pick a random number. So, these numbers correspond to the hotels. And these 4 hotels become the random sample of 4. Notice, all of them had exactly the same chance of getting picked, so there's no systematic bias. So the purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population on the basis of a sample is called inference. So why should we rely on this random sampling? Why is it so important? Well, we need to eliminate bias in selecting samples from the list of available individuals. We can then apply the laws of probability, and this will allow us trustworthy inference about the population. we'll be able to quantify certain things. For example, the results from random samples come within a certain margin of error that set bounds on the size of the likely error. Again, we can quantify it. We should, of course, understand that larger samples will give better information about the population than smaller samples. That's the law of large. There are other types of sampling designs. Here's one of them. The basic idea is straightforward. Take a simple random sample from the population, use your sample results to gain information about the population. Sometimes there are statistical advantages to using more complex sampling methods. One of these examples is called stratified sampling. And we take the population and divide it into subgroups called strata. So in doing this, we first classify the population into groups of similar individuals called strata. Then we choose a simple random sample in each of the stratum and combine these to form the full. So, for example, you want to conduct a study of student satisfaction at your school. At your school, there happen to be 980 freshmen, 837 sophomores, 589 juniors, and 461 seniors. In percentages, that's 34% freshman, 29% sophomore, 21% junior, and 16% senior. So you may want your sample to contain freshmen, sophomores, juniors, and seniors in these particular proportions. That way your sample will be representative of the makeup of the population. Good sampling technique includes the art of reducing all sources of error, and there are plenty of places where error can creep in. Undercoverage is one of these sources of error. This occurs when some groups in the population are left out of the process of choosing the sample, as in the case with the Dewey versus Truman. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of incorrect responses in a sample survey leads to response bias. And the wording of questions is the most important influence on the answers given to a sample survey. I'll talk about that. So, for example, here is I'm identifying as a biased question. Don't you agree that campus parking is a problem? Well, you're probably going to agree. The question is expecting you to agree with that. A revised question would be simply, is parking on campus a problem? This question doesn't lead you in any particular direction. There are double-barreled questions. For example, do you agree that campus parking is a problem and that the administration should be working diligently on a solution? Well, there are actually two questions there, not just one. So which one should you answer? Well, a revised question might be, is campus parking a problem? First, and then if the participant says yes, then you ask, should the administration be responsible for solving this problem? Confusing questions. What do you think about parking? That's so vague and ambiguous, a respondent could answer practically anything. And if you have a particular question in mind, or that you want certain responses about a particular problem with parking or something like that, you should make that clear. So, one way might be to say, what is your opinion of the parking situation on campus? That's more specific. And you're likely to get more specific. You're likely to get answers that more specifically respond to this particular question. Here is a question that actually showed up in a survey sent out by the National Republican Committee. In your estimation, have the job creation policies funded by the Obama administration in the past 5 years been successful, or have they been excessively costly and wasteful boondoggles? I'm not sure I really need to comment much on whether that's biased or not. To review, it's important to identify the population, that is, the group of individuals to which you're going to draw conclusions from your sample, and then this allows you to identify the individuals and to take a sample, a subgroup of that population. We're able to identify bad sampling methods in order that you can avoid some of those. How we can select a simple random sample, describe different sampling methods like stratified sampling, and recognize some cautions about sample surveys.